and welcome to this 4-part webinar series hosted by the GrabMaps team, where we take you behind the scenes and deep dive into the core pillars of our map-making solution: hardware, collection, KartaMaps, and KartaPlaces. My name is Nick Preston. I'm the product lead for KartaMaps here at GrabMaps. In this session, I'll take you through an introduction into KartaMaps, which is the map data sitting behind GrabMaps and powering our location services and experiences here in Southeast Asia. During this session, I'll address some of the challenges that we've faced building a map in this region, how we've benefited from working collaboratively with the OSM community, and how the team has developed a set of technologies to exploit the massive amount of data that we're collecting. This presentation should provide a sense of how we have taken on the task of becoming self-sufficient with our map data and how we can support others take on a similar feat. Okay, let's jump in. Let's start by looking at some of the facts about Southeast Asia to understand why this is typically a really challenging part of the world to build a map. Firstly, Southeast Asia is a huge region. With a population of over 680 million, it has about 25,000 islands and over 22 million kilometers of roads just in the 8 countries where Grab is active. As you would expect, this vast area is difficult to access, let alone map, by any single centralized data collection and map-making organization. The reality is that large parts of the region are still unmapped or undermapped. And sadly, it's not possible to rely on existing high-quality open data, which is available in some other regions and more mature markets. And as with other parts of the world, things are always changing. From new roads, buildings, bridges, and tunnels, there's always something new to capture. We also have some unique situations here in Southeast Asia. We are constantly learning and uncovering more about the region and what is required to build great map content. A high-quality map should always allow users to understand local conditions. In our context, they should help to understand which roads are the quickest, have the least traffic, or even which roads are suitable for the type of vehicle that you're driving. I wanted to include these 2 short videos to give a sense of some of the common conditions throughout the region. Narrow roads and laneways are very common. Some would consider these small laneways irrelevant, but as you can see, they often contain residential addresses and even merchants. And just like all the other merchants on the Grab platform, they are now servicing more than just their local customers, which means drivers need to be able to find them on the map and actually have the right vehicle to get to them. Things like street names or house numbers are also not given around here, meaning that the map must contain sufficient contextual information to help people work out where they are and where they need to be. In the process of launching our own map and becoming self-sufficient, we play around with several different solutions to build and maintain map data effectively and still deliver on our business needs. After several iterations, Grab landed on a solution which actively collaborates with OpenStreetMap, or OSM, and leverages the high-quality base map, which is largely built and maintained by the mapping community. With about 9 million OSM users who contribute to over 100 million edits per month globally, OSM has a large, skilled, and engaged community of mappers who care about providing a high-quality resource for others to use. We recognize the value and the integrity of the OSM community and the decentralized nature, which helps cover significantly more ground than any single organization with finite resources. For these reasons, Grab's decided to pursue a model which uses OSM as a foundational layer which we build on top of. But we do not simply take from OSM, and since 2018, we have been actively contributing to the OSM map. In this time, Grab has contributed almost 25% of the total edits in Southeast Asian countries, including mapping of new roads, street names, building footprints, and other attributes. In addition to contributing directly into the map, We're also engaged with the community in a few other ways. We work with universities as part of our GeoStars program, educating younger users on maps and mapping technology. We enable collection and sharing of street-level imagery with Grab's KartaView technology. And finally, through the creation of Street Complete campaigns, which highlight areas of the map which are in need of attention. All of these programs aim to increase engagement with the OSM community and support building a great product for others to also use. But while OSM is a rich source of data, it cannot be expected that navigation attribution is added and maintained consistently across the region. So in order to support both Grab's internal business and our external customers in Southeast Asia, we build on top of OSM and enhance certain attributes which enable high-quality routing and effective turn-by-turn navigation. To do so at scale and cost-effectively across 8 countries, GrabMaps has developed a series of map-making pipelines which leverage the huge amount of data that we have access to and automate map edits where possible. Automation being a critical component here, something which is not supported by OSM. As a result, to optimize our efficiency, the team developed a standalone repository for Grab-generated map data. I'll dive into the complete process of how we merge the datasets in a couple of slides. Now I'd like to dive a little bit deeper into how we transform our raw data into valuable map attributes. There are 3 primary pipelines which enable Grab to do this and build on top of the foundational map data which we leverage from OSM. These are street-level imagery, probe data, and topology-based rules. Starting with street-level imagery, which is a really powerful data source for computer vision-based feature extraction and trustworthy ground truth for manual verification. The street-level perspective provides an excellent view of buildings, roads, signage, and other infrastructure which supports map building. Today, we're collecting over 100 terabytes worth of imagery each month and continue to scale up collection around the region. For Grab, this is all captured using in-house technology. Street-level imagery is typically a pretty expensive endeavor, from the hardware to the logistics and processing costs. However, my colleagues in the hardware and data collection teams are doing an amazing job in making it more accessible than ever. Please tune in to Alex and Shongquan's webinars for more details on this topic. On the KartaMaps side, feature extraction from imagery is primarily focused on capturing sign-based rules. Currently, we support models for 7 different countries and can detect over 200 variants of road signs. We've also recently just deployed a really nice model which infers vehicle type accessibility from road width. This is really useful here in Southeast Asia to map all those narrow laneways like you saw on one of the earlier slides. We are also using street-level imagery for point of interest and address creation and verification, but you'll have to tune into my colleague Vinay's webinar, which will explore that topic in more detail. There are several steps performed by our machine learning team to go from detecting something in an image to generating a map attribute assigned to a specific section or sections of road. This starts with the initial detection, simply finding a relevant sign in a single image. This is followed by segmentation to isolate the sign, grouping to understand if there's any associated conditions such as time of day or vehicle type, positioning and facing of the sign to help determine the road it applies to, clustering of multiple detections, and then finally, the creation of the map feature. With individual ML models for each of the Southeast Asian countries, we also benefit from the collaboration with our country teams for local insights and tight feedback loops from our team of analysts to provide training data and refine these models continuously. The goal for us is to continuously improve the confidence in our detections as we gradually push for more and more automation in our map-making process. While these existing models can be reused outside of Southeast Asia, we expect a certain amount of training data to be required to optimize for local conditions in different countries to get the best results. The second pipeline is GPS probe data. This data is collected from Grab's extensive driver network. And capturing this actually serves many use cases, like helping consumers understand where drivers are, if they're moving, how far away they might be from a pickup or drop-off. They also allow Grab to review certain trips for safety and compliance and resolving any issues. A single trip in isolation tells us where the driver went, which direction they were traveling, and how fast they were traveling. Low volumes of this data may give us an indication of commonly used roads or where roads might be missing or have been mapped poorly. But it's when we start to look at this data at very high volumes where it becomes a powerful tool in enhancing simple base map into one which can provide accurate routing and navigation. We use batches of this data to supply enough volume which allows the team to extract insights. The team has determined that generally 6 to 9 months worth of probe data is the right amount to produce high quality detections across the network in an entire city. For reference, a city like Jakarta, we produce over 20 billion probe points every single month, which is a significant amount of data. Unlike imagery models, which are localized, our probe pipeline is country agnostic, meaning we use the same code for all countries. This also makes it very easy for our partners to deploy without the same requirements of localization. For us, there are 3 key attributes which are immensely impactful for generating effective routes. These are one-way roads, turn restrictions, and two-wheeler and four-wheeler road accessibility. The output of this pipeline is a series of detections which indicate where road rules may apply, but which are not already represented in the existing map data. This allows us to focus on the value add to the database and not starting from scratch with each batch. High confidence detections are automatically ingested into our standalone layer, while lower confidence detections are manually reviewed with simple one-click validations. While we again look to automate as much as possible, there are still situations such as time-based restrictions, reversible roads, or people who simply ignore the road rules. We're working hard to recognize and account for these situations. They're still a work in progress. The final component of the map-making process I want to touch on today is our set of road topology-based rules. These are a set of rules which are applied to the underlying road geometry, which elevate the content and improve the route creation and navigation. The most impactful of these rules are what can be referred to as logical turn restrictions. While not signposted, these rules are required so that the routing algorithm behaves in the way a human would expect it to. A good example of this, which is shown in the slide here, is where we have a dedicated lane to make a turn, in this case, to the right. While it's not illegal, as a driver, you would never choose to make the turn at the intersection, instead taking the turn lane. So if we take a step back and look at the map creation and release cycle, it looks something like this. Starting with the OSM base map, we continue to regularly update it with new and missing geometry. The next step is to generate detections from imagery and probe and convert these into map features which are ready to be ingested into the map. Throughout the region, we are collecting hundreds of billions of probe points and millions of images every month, which help us gather these insights. From here, high confidence detections are automatically ingested and lower confidence detections go through manual review before being added. Validation of detections is followed by map compilation and QC. This step includes a series of integrity checks to ensure that the database is sound and we're not releasing any poor quality data. Topology-based attribution and other admin-wide rules are also applied during this fully automated step. Maps are currently released on a weekly basis with the ability to release daily on an as-need basis. The final step is a series of maintenance processes, including feedback from users, drivers, and also data mined from our location services to expose errors in a bid to keep our data fresh and accurate. With this process, we're able to leverage the power of a huge decentralized mapping team from OSM. We can build on this strong foundation with scalable processes that exploit Grab's billions of probe points and millions of images. While we are still a little way off full automation, even partial automation offers an opportunity to significantly reduce map-making costs while maintaining quality. And finally, the output map is fully ODBL compliant. All of the detections which come through our pipelines are made available to the community if they wish to review and update them in OSM. And it was earlier this year that we launched the KartaMap across all 8 countries where Grab is active. This was a culmination of a huge amount of hard work and a very proud achievement of the team to be supporting Grab users throughout the region. While it's a fantastic achievement, as a mapping team, we often focus on the importance of adding kilometers of roads or thousands of new attributes in a given city, but it's important that we maintain a view of why these attributes matter. For a consumer, the convenience of receiving accurate and effective turn-by-turn directions mean they arrive on time and experience very little stress whilst making a trip, and that's great. However, for a company like Grab, providing mobility and delivery services, this translates directly into driver efficiency and reduced time wasted. We know that when drivers experience errors in the map, it adds time and frustration to their trips. The impact of this is multifold. When driver trips are longer than expected, it means they're not compensated fairly. If this happens consistently, then it's not unreasonable for them to explore other platforms to drive on. We also lose trust on the consumer side by missing ETA promises or causing delays. Something more difficult to quantify is also the stress which is experienced on a daily basis by drivers who might be spending more than 12 hours a day on the road. Delivering a delightful experience to them, which makes their job efficient and reduces stress where possible, is incredibly valuable. At Grab, we're always looking at ways to continue to enhance the effectiveness of our platform, but also how we can provide a truly differentiated experience which can reduce the stress of being on the road all day. Whether it's by delivering the most accurate real-time information on traffic or road closures, highlighting or avoiding poor quality roads, which may be dangerous for two-wheelers, or even giving drivers the opportunity to avoid heavily polluted or poorly lit and high-risk environments. At Grab, we believe there are plenty of opportunities to deliver a truly excellent experience with the help of a good map. That brings me to the end of this webinar. Thanks for tuning in. I hope you found it an interesting insight into the map-making process here at Grab. Do check out the other 3 webinars in this map-making series on our hardware collection and places. And if you'd like to learn more about GrabMaps. If you have any questions about our solution or would like to get in touch, feel free to drop us a note at grabmaps.contact@grab.com. Thank you.